Alright, let's get started. So today we're going to go over how to do an air-free precipitation of cyclic polyacetylenes in the beach group. So first you need your methanol. We're going to add that to the flask. So the rule of thumb for this is you need 10 times as much methanol as you have of your reaction mixture. So our reaction mixture is 7 milliliters, so we need at least 70 mils of methanol. So pour about 70 mils approximately into the round bottle. So then we're going to need to sparge this methanol to make it air-free. So to do that, we need to seal it with a rubber septa first. We'll get that on there. So if you don't know how to get these on there, a good trick is you want to bend over one half first, put your thumb on that bent over half like this, and then we want to grab the other half and then lift it over. It's wet, so I'm struggling a little bit, but you should find that that will help a lot. So then we're just going to clamp this back down, and then we're going to sparge this with argon and or nitrogen. We want to make sure we have stirring going. So here we have our nitrogen line, which we need to attach a needle. So then we're going to open up our argon, so we have argon flowing. We're going to insert that through the septa. Make sure you go through the center so it's easiest. Make sure you clamp it well. Clamp this. So once our argon needle is in, our argon inlet needle is in, we're going to add an exit needle, and then you should see it start to bubble. So you see it's not bubbling, but then once we add the sparge needle, it will then start to bubble because the gas now has somewhere to go. So by bubbling argon through this for about 15 minutes, all of the oxygen dissolved in this methanol will be replaced with argon gas instead. So we're going to let this bubble for about 15 minutes, and then we'll come back and then show you the rest. Alright, so we're going to finish showing you how to precipitate. So once you have your finished reaction, so all your monomers been consumed, this is one hexine, which finishes in about 3 minutes. So you should see a color change, should get slightly more viscous. It's a good indication of your polymer. So since this is air sensitive, we're going to seal this with a rubber septa inside the glove box, and then we're going to exit it and precipitate it air-free just using syringe technique. So we're just going to seal it with a septa and then exit it. Alright, so once we have our polymerization solution exited from the glove box, as well as our degassed methanol, so this has been sparging for about 15 minutes, so we need to end this sparge. So first we want to take out the vent needle on top. It's very important you take out the vent needle first, because if you take out the argon needle first, air can diffuse back in through your vent needle back into your reaction, and then you'll no longer have air-free methanol. So make sure you take out your vent needle first. You'll see it should stop bubbling, and then you want to make sure you pull this inlet needle above the solution, and then we're going to pull this one out as well. So then we're going to need to withdraw our solution from the reaction mixture air-free. To do that, we are going to need another argon inlet. This doesn't seem very strong. Turn this up a little bit. Alright, so now we have nice and strong, right? So, to withdraw this, we're going to purge the needle first. So we'll just put our inlet in, assemble our syringe, and then we need to sparge the syringe. So to do that, we're going to simply put the syringe in, so it's inside the vial. So this is exposed to argon now. So then we're going to fill the syringe full of argon. And we want to do this slowly, because imagine you can only put in so much argon at a time, so don't do this too fast. So about all the way, even past the last line, to make sure you sparge the entire syringe. So then pull it out. Make sure you pull it out by the top of the needle. Pull it out by this, your needle might fall off. So I usually pull this out, and then I just push it out like that. And that's one cycle. So then we need to repeat that 2 more times to fully degas this syringe. Going to suck out all of the solution into our degas. syringe. Again, make sure you go slowly. If you go too fast, you'll pull up a lot of just air, and then you won't be able to get it all. It generally helps if you use a thicker needle, wider bore needle. This one is a little thin. So it's really important when you're working with hexine, for example, that you do this polymerization at a monomer concentration below 0.2. So if you do it at a monomer concentration of 0.5, the solution will actually be too viscous to pull through a syringe. So this reaction was done at a concentration of about 0.2. And it doesn't matter as much with phenylacetylene. You can do a lot bigger range of concentrations of phenylacetylene. Doesn't have the same viscosity problem, but with hexine and other aliphatic alkynes, make sure you do a very dilute polymerization so you can actually isolate your polymer. If you plan to do it in this method at least. There is other methods you could do inside the box. Now we have all of our solution. We're simply just going to transfer both the needles. So first we're going to transfer this needle containing our reaction mixture. Make sure you go to the middle. We're going to make sure that it goes right into solution. Then we're going to add our inlet needle one more time. Just make sure we stay under argon in case this takes a while. So now it's really important that you add this slowly and dropwise to get the purest polymer possible. So, and additionally, you want to make sure that the polymer actually precipitates. So as you can see at the beginning, the polymer doesn't actually precipitate very well. You can see it almost looks jelly. And so what will happen is that slowly over time, the toluene will diffuse out. So you can kind of see how the one on the left is jelly and the right has solidified up a little bit. That'd be hard to see. But the moral of the story is that it doesn't precipitate instantly. You do need to allow it to stir for some period of time before it will actually precipitate well. And so yeah, so now we're just going to slowly add this solution dropwise to the methanol and then keep stirring it until all of the polymer has become opaque. So we can tell that the polymer hasn't precipitated fully when it is transparent. That means it still has solvent in it, but once it goes opaque, then we know that it has fully precipitated, right? Now we have our polymer precipitated. You can see it is very opaque. That's how you know it's all precipitated, right? So now this is air sensitive, so we want to do this next part as quickly as possible, right? So we're gonna open this, decant off the methanol, and then put the flask under vacuum. So you can also do this in a vial, so you just put the vial under vacuum or a centrifuge tube, but since we had a lot here, we did it in a round bottom. So we're just gonna pop this open. We're going to decant off all the methanol, so just pour off all the methanol, leave behind your polymer. So this will remove the vast majority of the methanol from the polymer. Then we're going to take the polymer and we're going to put it on the shrink line under vacuum overnight. So alternatively, you can weigh out your polymer over time and see once the mass settles. So once you stop losing mass, you know you've removed all the solvent. Alternatively, I like to just leave it under vacuum overnight because then you know it will be done at that point. So now we'll just leave this under vacuum overnight and then we'll take it down and then enter it in the glove box as fast as we can to make sure it gets the minimal amount of air exposure. But once it's in the solid state, it is much more stable. It's really the solution state that you have to worry about. So yeah.